Okay, well, we're going to talk about 3.1 functions. And the first step is to go through some vocab here. So understanding these different terms will help out. And really to do so, I'm going to break it into X and Y. So X has multiple names. One name is called input. So we call our X value input. The corresponding name to Y would be output. We also call X our independent variable. And the corresponding for Y would be dependent variable. In other words, Y depends upon what we put in for X, and that's why we call it our input. So when we input something for X, we get an output, okay? And Y is dependent on X because we have to input something before we can get the output. So it's kind of like, it's kind of like you getting something out of a vending machine. You input money and you get an output of chips or something. So your output is dependent upon your input. We also have another term called domain. Domain goes with X and range goes with Y. And we'll talk about those a little more when we do some examples. But just note that D comes before R in the alphabet, just like X comes before Y. That's a good way to remember those. And then relation and function. And we're going to see that here in a minute. I'll explain what a relation and function is. Okay, so just so you have this information down, that will be helpful as we progress. All right, so first, is it a function? What's the domain and what's the range? So I'm given this graph here, and notice I have different points, okay? I'm going to list these coordinates. Assuming I'm going up by 1, this is -2, 0. -2 on X, 0 on Y. 1, 0, 3, 1, 2, and 0. Oops, excuse me, not 0, but 2, 0. Okay, so a function is a function if in a picture it passes what's called a vertical line test. That means if I were to draw a vertical line at any point on the graph, I would hit a single point only. I would never hit more than one point at a time. So notice all these vertical lines I'm drawing, I'm only hitting a single point every time. There's no possible way for me to draw a vertical line and hit more than one point at a time on this graph. Therefore, this is a function. So is it a function? Yes, because it passes the vertical line test. And I'm going to write that in a different color just in case someone's taking these notes and it doesn't show up. I'm going to put the reason passes the vertical line test. Now, in order to be able to say this is why, you actually have to see a picture. If you don't have a picture, then you can't say that. Okay, our domain stands for our X values. So in this case, what are our X values? Well, our X values, there's a set of them. So when we say there's a set, we put it in set notation. So when you see brackets like this, that means a set. It usually means multiple answers or multiple solutions or multiple pieces. So we put brackets around it. It's called set notation. Okay. So X is equal to the set of -2, -1, 0, 1, and 2. And Y, well, Y is our range. Y is equal to the set of all of our Y values. Well, that would include 0, it would include 2, it would include 3, and then I start going back down. Notice I already have 2, and I already have 0, so I don't have to rewrite those. I just list those values. And that's how we do domain and range. By the way, this is a function because it passes the vertical line test. The collection of points of ordered pairs, that's what we call the points. Notice they're ordered pairs. That's an ordered pair. The collection of points is called a relation. So when you see the word relation, it says, hey, is this relation a function? Well, here is your relation, the connection of these, or the collection of these points. If there is only one set of points, that one set of points, that one ordered pair would be the relation. If there's 10 sets of points, then we would call them all put together a relation. Okay? So, is this relation a function? Yes, it is. All right. So looking at this, is this relation a function? Well, this relation, if we start using our vertical line test again, well, here's a vertical line. Oh, danger right there. That hits our graph in more than one point, or it hits more than one point on a graph. So we don't have to go any further. This we frown on. It's not a function. Okay, and once again, let me switch colors there. So is this a function? No. Does not pass the vertical line test. And I like to even say x equaling -2 has 2 different outputs. So in other words, when I get of 2 different values. This has a coordinate of -2, but it has a y value of -3, and this has an input of 2, but it gives me an output. So think of it this way. You go to your vending machine, you put in your money, and you push the button for your chips, and it drops out, I don't know, a bag of carrots or something. And you're like, what? I want the correct output. Well, there were multiple outputs. You just happened to get the one you didn't want. Okay, that's what's happening there. Your input can only have a single output. Okay, and so it still has a domain and range though. So I'm going to list this is -1 and 0. We have 0 and 3. Up here we have 1 and 4, and here we have 1, 2, 3, and 3. Okay, so if I'm looking at my x values, well, x is equal to the set containing -2. That appears twice. Only have to list it once. Usually put them numerical there. 0, 1, and 3. And then y is equal to the set of -3, 0, 3, which appears twice, and it's okay for the output to appear twice. That doesn't change. Oops. That does not change whether it's a function or not. And then 4 actually appears twice. All right. Let's take a look at another one. Is it a function? Well, looks like it passes the vertical line test. There's nowhere on this graph where I could draw a vertical line and hit that graph more than once. I could keep trying, but it wouldn't happen. So yes, it passes the vertical line test. So yes, it is a function. Okay, well, the domain this time. Notice this has a line. This is called continuous data because my line, or all my points are connected in a line. And so when you have continuous data, you have to think of it in two different ways. First, you have to look at it like this. My x value starts right here, and it continues along the x-axis until I get to right there. So I start at -2, and I end at 1, 2, 3. So x ranges, or I guess range isn't a good word because that stands for something else, but this is my x value here. X has a domain of between -2 and 3. And it's equal to because there's a closed circle right there, or there's no open circle. So that's how we write it. Sorry about that. -2, x, 3, and we got it. Now my range stands for my y values. So I have y. All right, and I'm going to start down here, and I'm going up to right there. Well, that is 11 on y. And I forgot to put the value in here, but this is supposed to be, so you know what, I'm going to have to write that in. This right here is supposed to be -1.3. I forgot to put that in. So y is at -1.3 right there at the bottom of the graph. Okay, so that means my graph goes from, on the y-axis, it starts here at -1.3, and it goes all the way up, it stretches all the way up to right here at 11. So y is in between those. Now it's a little difficult to see, so I'm going to rewrite it in numeric form. -1.3, 11, and I'm going to put the y in between. And once again, since there aren't any open circles on the ends, it has the less than or equal to. So y is in between these two values. That is my range. It just says where y exists in graphical form and where x exists in graphical form. All right. So looking at this, I got to erase the piece that actually I put on there. Okay. So looking at this one in terms of a function, well, is it a function? When I start looking at the picture and I start doing my vertical line test, like, whoa, look at these vertical lines. They keep hitting the graph in more than one spot. So no, does not pass the vertical line test. Okay. And then when we look at our domain, let's go ahead and erase those there. All right. When I'm looking at my domain on this, I'm starting right here, and I go all the way out to here on the x-axis. So my domain starts at, go ahead and bring that down, -1. It goes all the way to 15, and x is in between. So there it is. So I have a domain, -1, x, 15. My range, if I look at it, well, my range actually, the lowest point on my graph is right here, and my highest point on my graph is right up here. So my range stretches all the way there. So to kind of see where I'm at 1, 2, 3, 4 on y, and my lowest part is way down here, and that is at -3. So I go from 4 to -3, all the y's in between. So -3, y, 4, you just put the numbers in numerical order, and there we got it. Domain and range. So if it's a line, you have that that and situation, that compound inequality piece. Okay, so looking at it in terms of points. All right, so now that we don't want to graph it every time, but if you recall, back when it wasn't a function, if we look at just points, whenever you had x values repeating, it wasn't a function because you had them go into different y values. So when you're just looking at points, rather than having to graph it, if I were just to focus on these points and just look at my x values, if your x value repeats, which in this case it doesn't, But down here, notice it does. It repeats right here. We get a 5 and a 5. Well, if they go to different y values, which they do down here, then it is not a function. Because if I were to plot those points, you would end up with, now I don't want you to have to graph each of these, but I'm just going to show. Okay. You'd end up with that point at 5, 2. And you would end up at that point with 5, -1. And they wouldn't pass the vertical line test. Now the goal is not to have to draw it. You can't, I don't want you to use, well, it doesn't pass the vertical line test as your reason. I'd rather you say the input of 5 has 2 different outputs. Okay. And so is this a function? Yes. Every input has a different output. Different. That's really bad, different. That's going to drive me nuts. So I'm going to rewrite the word different because I don't want to be different. Okay. Your domain, well, since they're just points, we go back to set notation, where we just list our x, -4, -3, 4, 7, and 1. So we're just listing our x's. And then our range would be just listing the y values. So the remaining, we have our 2, our 5. We'd have 2 again, so we don't have to write it again. A 9, and then we have 5 again. We don't have to write the 5 again. So there it is. Okay. Our domain down here, well, we have 5. We have 3. We have -4. We have 8. And then we have 5 again, so we don't need to write that again. And notice I did not put them in numeric order. A lot of times you should. I mean, -4, 3, 5, and 8. It would be a lot better if we actually listed it as -4, 3, 5, and 8, putting them in numerical order. Okay. And then my range, well, circle our domain there. But then our range would be all the leftovers. So we'd have y is equal to, and then we have 2, -1, 2, 0, -1. So -1, 0, and 2. Sounds like those are the ones. So -1, 0, and 2, and then the -1 and 2 repeat. All right. I think we got one little more piece, and that's it. So when we're looking at it in terms of a table, so now it's a kind of a different way of looking at it. But once again, we're just looking at inputs and outputs, our x's and our y's. So if you think of this is a coordinate, and I don't want you to have to write them all as coordinates, but it's just a coordinate. So if your x's repeat, which in this case they don't, okay, so since they don't repeat, it's a function. Is it a function? Yes. Same reason. Each input has a different output. The domain, well, domain is not y, it's x. So x equals, well, 1, 3, 6, 0, 2. So numerically, that would be 0, 1, 2, 3, and 6. Okay, that is my domain. Then my range, y equals, well, 5. That's all it equals. So you didn't have to put it in set notation. You could have just said y equals 5. Okay. Or that graph would look something like this, by the way. It'd just be a straight line at y equals 5. So it passes a vertical line test. It wouldn't pass a horizontal line test, but it'd pass a vertical line test. Okay, the last one, this is called a mapping diagram. So if you see that term, that's what it is, mapping diagram. And all that does is it really says, well, 2 goes to 3. So really that means you have the ordered pair 2, 3. 5 goes to 0, so you have the ordered pair 5, 0. -1 goes to 7, so you have the ordered pair -1, 7. -1 also goes to 6, so you have the ordered pair -1, 6. So when you're saying, is it a function? Well, notice this input goes to 2 different outputs. And you can see it when you list it in ordered pair format. So no, the input -1 has 2 different outputs. Hopefully the domain and range is pretty easy again. Domain x equals, well, 2, 5, and -1. So -1, 2, and 5. And then the range y equals, sorry I keep switching up colors like that, but y equals 3, 0, 7, and 6. So 0, 3, 6, and 7. All right, there it is, 3.1 function. Good lucky.